Okay, so welcome everyone. My name is Mark and I will be your tutor today. So just to let you know, we are recording this session. So if you cannot fully attend the session, that's fine. I also want to attend you that we are recording it and that if you ask a question, it will be recorded. And also, if you turn on your camera, you might be visible. Okay. But personally, I would prefer it if you would ask questions via the microphone, but else you can also do it via the chat, of course. So let's make this an interactive session, just as when we are in a normal class. And yeah, I think that's what we can do for today. Okay, so here's the table of contents. What are we going to do? We're going to discuss three main topics. The first topic is about data. That's just theory. It's not that difficult. It's just the start of the course. What type of data do you have? Quantitative, qualitative. That's basically the start. It's pretty easy. It's just theory. Then we're going to talk about descriptive statistics. A lot of those you already had with the business mathematics course. You have the standard deviation, the covariance, how do you make a box plot, things like that. And this is the most important topic of today, also the most difficult topic, and that's about probability theory. So especially this topic will be very nice to discuss. We're going to practice a lot of exercises with it. And then at the end of this session today, week one will be very clear to you, I hope. Okay, so let's get started with the data, the theoretical part. So you have three sorts of data according to this classification. You have categorical, that doesn't have anything to do with numbers. So for example, the company you work for, so the name of the college major. You are guys are doing IBA, right? Which you could also have done EBE or business administration. That doesn't have anything to do with numbers. Okay. Then if you're talking about numbers, we have discrete numerical and continuous numerical. What is the difference between discrete and continuous? Well, with discrete, the outcome of the variable can only take whole numbers. For example, the amount of peanuts in a bag. You have 1 peanut, 2 peanuts, 3 peanuts, or maybe 0 peanuts, but you will probably not have half a peanut. The same holds with the amount of credits you can get for your education. You will have for this course 6 credits, but you will never get a quarter of a credit or the square root 2 of a credit, for example. Okay. The amount of persons in this class is also discrete, right? Okay. Then you have continuous numerical. Those are the things like the weight, distance, volume. Those are numerical, continuous numerical variables, because you're not necessarily 1 kilogram or 2 kilogram. You can also be half a kilogram or a quarter of a kilogram. And that's pretty important for the probability theory, because there are literally infinitely many possibilities if you have a continuous numerical number. So not only whole numbers, but you can come up with infinitely many numbers. You have 0.001, 0.002, etc. Infinitely many possibilities. Okay, so let's do an exercise about this. The length of a TV commercial. First of all, is it numerical or categorical with A? You can just say it. You can just use your microphone. So is it numerical or is it categorical? Okay, see it in the chat. It's numerical indeed. And then is it discrete? So can it only take up on whole numbers, or is it continuous? Do you guys have an idea? Yes, very good. It's continuous indeed. So A, continuous numerical. So I will call it CN. Okay. Then B, the number of peanuts in a can. Is that, first of all, numerical or categorical? Well, of course, numerical, yes. And then is it discrete or continuous? and that's indeed discrete. Very good. So here we can say discrete numerical. Okay. Then the occupation of a mortgage applicant. So basically your job. Is that categorical or numerical? Has it anything to do with numbers? No, it's indeed categorical. It doesn't have anything to do with numbers. Very good. D, the flight time from London Heathrow to Chicago. Categorical, numerical. Well, time is obviously numerical. And it's indeed continuous because you're not traveling necessarily 8 hours or 9 hours. You can also travel 8.5 hours, for example. So indeed, continuous numerical. Very good. Okay. And then here below, you can also see the answers. And we did it correctly. All right. Here you have the measurement level. There are basically 4 situations. It can be qualitative, so it doesn't have anything to do with the numerical value, or quantitative. Given that you have a qualitative measurement level, it can be nominal or ordinal. Okay, what is nominal? With nominal, there is no order. So you, for example, you're a male or female. There's no order, no hierarchy. With a football field, you have a striker, a goalkeeper, a back, and it's not necessarily that one is better than the other, right? So then you have a qualitative nominal measurement level. You can also have a qualitative ordinal measurement level. There you do have an order. There you have a hierarchy. So for example, in the Dutch education system, we have MBO, HBO, and WO. And the idea is that if you, for example, if you finish the HAVO level, you can be admitted to those two, but you cannot be admitted to the WO level. So there's some sort of a hierarchy in that system. And then you have an ordinal situation. So it still doesn't have anything to do with quantitative data, but there is a strict order in it. Also the ranks in the military, right? Those also are a qualitative ordinal measurement level. The ranks, you have the general, the colonel, etc. Okay. Then the quantitative measurement level. There you are working with numbers where they actually have a meaning. And then we distinguish between the interval and the ratio. Okay. The interval is a bit strange because there the zero is just arbitrarily chosen. So for example, with temperature, the zero is chosen randomly. We just said, okay, where does water freeze? Okay, great. We call that 0. Where is water starting to boil? Okay, that's 100 degrees Celsius. So that's just randomly chosen. We could also have used another substance like alcohol, and then where does alcohol freeze? Where does it boil? And then you get a different scale, right? So for example, with temperature, that's an interval because there the 0 is chosen randomly. Most quantitative stuff is a ratio. So for example, the number of goals in a match, there the 0 is not random. If you have a 0 of goals, you really have 0 goals, right? The salary of your employee, also the 0 is not randomly chosen. And here I have a nice tip. For example, if you can say you scored twice as many goals as your opponent has, then it's a ratio, right? But if you, for example, have 20 degrees compared to 10 degrees Celsius, then you cannot say it's twice as warm, right? Because it's not, it's basically a bit more random than that. So with a ratio, you can really say your salary is twice as high as somebody else, then it's a ratio, for example. And also, again, the 0 is not chosen randomly. So let's do some exercise about this. Okay. So the number of hits in the game won of the next World Series. So the number of hits, is that quantitative or qualitative? So number of hits, qualitative or quantitative?
Quantitative.
Yes, quantitative. And is it a ratio or an interval? It's, what do you say? It's a ratio, right? Yeah, it's a ratio, because the 0 is not random. If you have 0 hits, you really have 0 hits, right? And if you have twice as many hits as your opponent, then you really have twice as many hits as your opponent. Okay, so this is a ratio. The standing in the American League East among 5 teams. What do you guys think about that? So here, you might think it has something to do with numbers, because you have the first person, the second, the third team. But actually here you indeed use ordinal, very good. Because it's just a classification to say it's the first team, the second team, the third team. And there is a hierarchy in it, so therefore it's ordinal, very good. So ordinal. Okay. Then the third one, field position of a baseball player, catcher, pitcher, etc. First of all, is this quantitative or qualitative? It is qualitative, right? Very good. And is there a hierarchy in it? Is there a hierarchy? No, there's no hierarchy. So therefore, it's nominal, right? It's qualitative and no hierarchy. So then it's nominal. The temperature. Here, the 0 was chosen randomly. So what was this then? Yes, it's an interval. Very good. The salary from a pitcher, it is quantitative? Is it a ratio or an interval then? Ratio or interval? Yeah, it's a ratio. Very good. Because you can say your salary is twice as high compared to somebody else. So a ratio. The freeway traffic on an opening day, light, medium, heavy. Is this qualitative or quantitative? This is qualitative, right? It doesn't have anything to do with numbers. Okay, is there a hierarchy? Then it's ordinal. Or is there no hierarchy? Then it's nominal. Yes, it is ordinal. Very good. There is a hierarchy here. Okay, so I will open the solutions again, that we can check if we did it correctly. Ratio, ordinal, nominal, interval, ratio, ordinal. Very good, guys. Okay, so that was basically the first topic. So that was not that difficult, right? That's just some theory. Okay. Then the second main topic of today, this is a bit of a bigger topic. That's about summarizing data. Pretty important. And I would say that this is relatively important, but the third topic, again, about probability theory, that will be the most important topic of today. Okay, so let's talk about summarizing data. You already did this with your business mathematics class, right? Maybe we can make a nice start with the following. So we have in this course the population, and you will see that you have the sample. So let's say that we want to know, we have the population that's as follows: all the men in the world, so about 4 billion people. And we want to know what their average is. We call that the mu. So this looks a bit like a U, but then the mu. That's the population average. But of course, in reality, you can never measure 4 billion different people, right? So instead, you will take a sample. You will just measure, let's say, 1,000 random people in the world, and that gives you your X bar. So again, the mu is the population average. You will never be able to calculate it because you cannot measure 4 billion people. And this is the X bar. That's the sample average. And you hope that that X bar is pretty close to that population average. And in week 3, you will see that we will do some tests about that. So we want to form a hypothesis about that mu because we can never know it. And using this X bar, we will reject or accept some hypothesis about it. Okay. Then you also have the standard deviation of the population and the variance. We'll show you how to calculate that and what it is in a second. But in your you can also never calculate this one. Instead, you can only measure your sample standard deviation. Okay. Then you have also, for example, the rho. That's the correlation coefficient from your population. The sample has R. What do we also have? You have, for example, the pi. That will be the probability of success from the population. And here you will have the probability of success from the sample. Okay, so it's basically the amount of times you succeed divided by your amount of trials.
Deze orde met een soort deels blauwachtig pareltje vond ik ook leuk.
Oh, so I muted her. So sorry for that. So that's the pi and the p. What do you guys notice if you compare those letters, right? So with the population, you typically always use Greek letters, while with the sample, you don't, right? That's how you can see it's a mu, sigma, rho, pi, Greek letters, X bar, S, R, P, non-Greek letters, right? Okay, there's one exception, and that's with the capital N. So this is the size of the population. So for example, 4 billion men. And this is the size of your sample, for example, 1,000 men. There you use capital N and lowercase n. That's basically the exception. Here you don't use a Greek letter. Okay, so that's a bit of the theory. So here on this slide, you see a lot of formulas. We're going to calculate those with some examples. So what you notice here is that this is the population formula, and then on the next slide here you see the sample formulas. It's almost the same, right? So let's look at the first formula. Here you use mu capital N, and here you use X bar lowercase n, right? Also with the variance you use sigma and here capital N, while with the variance for the sample you use the S. And you use lowercase n. And also there's something here that's called Basel's correction. So you do -1 here in the denominator. Okay, so let's just get started. So here's an example. I will go to the whiteboard. Okay. So let's say we have the following data. We have x is 5, -10, 20, and then y is 10, -20, 40. And this is moment 1, moment 2, moment 3 that we measure, okay? So first of all, what is my lowercase n? How many observations do we have in each sample? Any ideas? Is it 3 or 6, you think? It's 3, very good. So n is 3, okay. Then the first thing we want to measure is what is the x bar, the average of x. When you do it is you add up all those numbers and then you divide it by 3. Okay, so 5 minus 10 is -5, plus 20 is 15. That's what I get if I add all those numbers. Then I divide it by 3, and then I see that my sample average is 5. Okay. For y, we can do the same. 10 minus 20 is -10, and -10 plus 40 is 30 to get 10. Okay, so that's the average, right? So I just showed you how to calculate the first formula that you're seeing here. The next one is the variance. So this formula looks pretty difficult. Let's look with an example how it works. To get the variance of x, you first take the amount of observations you have, which is 3, and you subtract 1. That's because you're working with a sample. You have to do a particular correction for that. Just remember that. I open a bracket. I open another bracket. And then I take the first observation, which is 5. And then I subtract the average. And I square it. Then I take the next observation, which is -10. I subtract the average. And I square it. Third observation, which is 20 minus 5. And I square it. Like this. And the idea is that we're looking how much does the observation differ from the average. And it doesn't matter if it differs in a positive way or in a negative way, because we're going to square it. So if it is smaller than the average, we just square to make it positive, right? Okay. So let's look at what the outcome is. And I on purpose chose some numbers that are pretty easy. So for example, you already know that this is 0, so don't plug it into your calculator. This is just -15 squared. And this is 15 squared, right? And this is just divided by 2. Okay. So you can fill it into your calculator. Tell me what you get. Another way, by the way, to do it is that you know that 15 squared is 225. 225. And then divided by 2 here, right? So what is 225 plus 225 and then divided by 2? Maybe you know it. So let me guys know if you have the answer. See the first answer, indeed 225, of course. Okay. Did you have a question, Nada? No? Okay. All right, so let's try to interpret this number. So the average is pretty obvious, I think, but what is the variance? Well, if all the numbers are the same, so you always have 2, 2, 2, then the variance would be 0, because there's no variation within the numbers. All the numbers are the same, then the variance is 0. The further away the numbers are from each other, the higher the variance. So it's 0 when all the numbers are the same, and the further away from each other, the higher the variance. So this is 225. That's a measure for how much variation there is within the numbers. Okay, let's have a look at the variance of y. Okay, let me get my black marker. So I take the first number, which is 10, minus the average. Then I square it. I take the second number, minus 20, minus the average, and I square it. The third number, which is 40, minus the average, and I square it. What do you guys get? And again, I chose some easy numbers, so you already see that this is 0. Don't plug it into your calculator. This is minus 30 squared. This is 30 squared. which is basically 900 plus 900 divided by 2. So maybe you already know what you get. Yeah, it's very good, Kim. You get 900. Okay. So what is the interpretation here? The variance of y is bigger than the variance of x. So that means there's more variation within variable y compared to variable x. Okay, you can already see that, right? So x changes in between -10 and 20, so it fluctuates a bit, but y fluctuates way more, right? It goes from -22 all the way up to 40. So there's more variation within y. That's what we now calculated. Okay, so then I will erase this here. Then something else that they can ask is the standard deviation. So we just did those two calculations. Now we're going to have a look at the standard deviation. So the standard deviation is the square root of the variance. So it basically just scales the variance differently. The interpretation is still the same. So there's also the standard deviation will tell you how much variation do you have within your variable. And if it's 0, there's no variation at all the numbers are the same. And the higher it is, the more variation you have, of course. Okay. So what would be the standard deviation of x? So we already said it's the square root of the variance. What do we get? What is the standard deviation? It's 15, very good. And then the standard deviation of y? Yes, indeed, it's 30. Perfect. And again, the standard deviation of y is higher than x, so y has more variation in it. Okay, then we go back to the PowerPoint. Then there's something called the coefficient of variation. So with the coefficient of variation, you basically correct the standard deviation for differences in mean. So with the coefficient of variation, you correct the standard deviation for differences in mean. What do I try to say with this? Well, if you have a higher average, you typically also will have a higher standard deviation. Not because there's more variation, but just because you're working with bigger numbers, right? Okay, so the coefficient of variation corrects the standard deviation for that. Okay, so let's have a look. So you take the standard deviation, you divide it by the average times 100%. Okay, so let's have a look. Oh. CV of x. I take the standard deviation of x and I divide it by the average of x, right? So the standard deviation of x is 15. And we said that the average was 5, right? And then I get here 300%. If you denote it like a percent. So you get 3, which is 300%. Okay. How about the coefficient of variation of y? What is the standard deviation of y? That was 30, right? And what is the average of y? That was this 10. What do we get out of here? We also get 300%, right? And what is the interpretation of this? Well, on itself, y has more variation because it has a higher standard deviation, a higher variance. But if you correct for the difference in mean, you'll see that actually the variation is the same. It's just that y has a higher average and therefore it has a higher variation. But if you correct for that, the variation is actually the same. That's what this tells us. Okay. Is this clear for everyone? Or are there any questions so far? No questions? can I erase this? Okay, I see a question from Jonah. Wait, can you repeat what it means when the CV is the same? Of course. So we said that the variance of y was higher, right? So y has more variation compared to x, okay? But the coefficient of variation corrects for differences in the mean, because y also has a higher mean, right? So we correct for that, and then we see that the variation within the numbers is actually the same. And with variation, we mean, are all the numbers the same? Then the variation is 0, or is there a big difference in the numbers? And if you correct for the difference in average, you will see that actually the variation is the same. That's what we now know. Okay. Are there any other questions? No? Okay, then I will erase the calculations to make some space. And then we will discuss the covariance. I don't need this one anymore, so I will get rid of it.
We will get a formula sheet on the exam, right?
Yes, you do get a formula sheet. I'm not sure. I don't remember if you also have those in your exam, but the most important thing from this is that you know what it means, right? Because we're going to do a lot of tests about standard deviations and stuff. So it's nice if you know a bit what it is.
Okay, thank you.
Yeah. For example, can a variance be negative? Can a variance ever be negative? Do you guys have an idea? No, the variance cannot be negative. That's because when we did the calculation, we were always squaring, right? So here you can see it. We're always squaring the numbers. So if you square a negative number, it becomes positive. So therefore the variance cannot be negative. So it's 0 when all the numbers are the same, and it's positive if there is some variation within the numbers. Okay. Then the next one is the covariance. So with the covariance, we can tell something about the relation between x and y. The covariance can be negative, 0, or positive. If the covariance is negative, it means that x and y move in the opposite direction. So when x is high, y tends to be low. That's when the covariance is negative. If the covariance is 0, there's no relationship between x and y, okay? So the value of x doesn't predict anything about the value of y. Third situation, that's when the covariance is positive. If x is high, y also tends to be high. That's when the covariance is positive, okay? So we're going to calculate the covariance for our data set. So let's have a look. And then they use a thing as x comma y. Okay, so just as with the variance, you start by taking the total amount of observations minus 1. Then you open a bracket. Then you take the first observation of x, which is 5. And then you subtract the average of x, which also happens to be 5. Then you take the first observation of y, which is 10. And then you subtract the average of y, which is also 10. Okay. Then we go to the second one, which is negative 10 minus the average of x, which is 5. Second of y, which is negative 20, minus the average of y, which is 10. So yeah, exactly. Then the last one, the 20 minus the average of x, And then the y, which is 40, minus the average. And I hope you can now see the pattern, right? So here in this column, we basically wrote down this column here. In this column, we just subtracted the average. And then in this column, we basically inserted this column here. And then in the fourth column, we just had we subtracted the average of y. Okay, so now we can calculate this. We want to see if this is positive, 0, or negative. And I on purpose chose numbers that are easy again, because we already know that this will be 0, right? 0 times 0. Here you will have negative 15 times negative 30, which is 450, by the way. And here we have positive 15 times positive 30, which is also 450, by the way. So we get 450 plus 450 divided by 2. So what do we get? Any ideas? Yes, we get 450. Very good. And you can also insert this into a calculator, right? I wouldn't do it without a calculator myself. Okay, so this is positive. But what does this mean? It means x and y have a positive relationship. If x goes up, y tends to go up as well. You can see it from the data, right? If x is positive, y is positive. If x is negative, y is also negative. So they indeed tend to move in the same direction. That's what you can see with this positive covariance. Okay, is it clear what the covariance means? Okay. Now we're going to discuss the correlation coefficient. So this last one. With the correlation coefficient, it basically works as follows. You don't only want to know the direction of your relationship between x and y, you also want to know how strong the relationship is. So let me give you an example. It could be the case that when x goes up, y always goes up. Then you have a really strong relationship, right? But it could also be the case that when x goes up, y most of the time goes up, but not always. In the last case, the relationship is a bit weaker, right? So therefore, we want to calculate the correlation coefficient. The correlation coefficient doesn't only tell us the direction, but also how strong the relationship is. Do they always move in the same direction? Then you have a really strong correlation coefficient. Or does it most of the time move in the same direction? And you have a weaker relationship. Okay, and that's where the correlation coefficient is for. So how do you calculate the correlation coefficient? You take the covariance and you divide it by the product of the standard deviations. And then the correlation coefficient will always be in between -1 and 1. So it will be 1 if they always move in the same direction. And it will, for example, be 0.5 positive if they most of the time move in the same direction, but not always. Just to give you an example. Do you guys have an idea what -1 would mean? Let's see in the chat. Yes, indeed. They move always in the opposite direction with a -1, right? Always. With a -0.5, for example, they most of the time move in the opposite direction, but not always. Okay, so let's calculate it. The correlation between x and y is the covariance of x and y divided by the product of the standard deviations. Okay, so the covariance was 450. What was the standard deviation of x again? It's 15. Very good. And the standard deviation of y, we said that was 30, right? Okay, so what is the correlation coefficient that we get from this? Yes, it was 1. Very good. So this is the highest possible correlation coefficient that you can get. X and Y always move in the same direction. That's what we just calculated. Okay. Are there any questions so far? I will say one more thing about the correlation coefficient. Are there any questions about this so far? So you now should be able to interpret everything we wrote down here on the whiteboard. Great. Okay. So here is a nice scatter plot about the correlation. So maybe something extra. If you would have a correlation of 1, let's assume it is, then all the points are at one straight line. That's when the correlation would be 1. If it's not exactly 1, just a bit lower, you get a pretty nice scatter plot. So you can easily see this linear relationship between X and Y. It's not perfect, not all the dots are on the same line, so the correlation is not 1, but it's a really high correlation coefficient. Here you also have a positive correlation coefficient, but it's not that good, right? So it's a bit more scattered. And then you have a 0.5, for example. Here, there's no relationship at all between X and Y, right? The value of X doesn't predict anything about the value of Y, and therefore the correlation is 0 here, okay? Here, you will see that the slope is negative, and it is almost all at the same line. Not exactly, it's not -1, but it's pretty close, so it's a minus 0.9. Here you also have a negative relationship, so the correlation is negative, but it's a bit more scattered again, so it's not that strong, it's minus 0.5. This case is really interesting. Do you guys see a pattern here? Do you guys see a pattern in this picture? Does anyone see a pattern? Or is there no relationship at all? Who does see a pattern here? Or is there no relationship? In the 6th picture. Yeah. Something like this, right? But nevertheless, the correlation is 0. How can that happen? And the answer is the correlation coefficient only measures linear relationships between X and Y. So not quadratic relationships, for example. So what he will do is he will draw a line through it, and he will say, well, I see something like this, right? That's what he maybe will say. So the slope is 0 here, and therefore the correlation coefficient is 0. Wrong. This is a quadratic relationship. So it's something like this, right? Okay. So that's the correlation coefficient. So here's basically the example we already did. So it's also in the summary. You can just read it again if you want. By the way, you can also use star in your R on your exam, right? Is that correct? Can you guys still use R this year? So let me show you how that works. So forget everything that's already written here. If you want to do the same calculations with R, you can create a vector. So you say X will be the vector 5 minus 10, 20. That's what we already had. Oh, sorry, I forgot the C. I'm sorry. So X C 5 comma minus 10, 20 like this. So now you create the X, and then you can use Y will be 10 negative 20, 40. That's what we already had, right? What you can do then is you can, for example, calculate the mean of x. So remember the mean was, I think it was 5, right? The mean of x. So now we should get 5. And there you go, right? The mean of y, I think it was 10, right? So there you go, 10. The standard deviation of x, that was 15, right? So there you go. The standard deviation of y was 30. So this should give us 30. There you go. So that's basically how R works. You can also use it for the covariance. So covariance of x and y, that was 450. There you go, right? So you can also do those calculations with R way more efficient. The correlation as well, correlation x, y, 1, just as we calculated manually. So now you know everything was correct that we did. So you only have to focus on this part, not you can ignore everything else above. So you create the vectors and then you can also calculate those things we calculated manually. All right. So we go back to the PowerPoint. And by the way, we will have a break in I think half an hour or something. Okay. If you want, we can also do it earlier. We can also do 2 breaks. Well, what do you guys actually prefer? Would you guys want to have 2 breaks or 1 big break today? Because it's a pretty long session, of course, especially with the computer, it's pretty tough. 2 breaks, okay. So shall we take a break at approximately 12 o'clock? Just after the 1 hour? Because I think the majority voted for 2 breaks. Okay. So let's have a look at the geometric mean. So for example, with stocks, let's say that you start with 100 euro, right? And then it doubles. So you have a 100% return on your investment. So it goes times 2, right? But then you make a loss of 50% on your stock. So then it multiplies by 0.5. You see that? Well, the arithmetic average of 100% and 50% would be 25%. Do you guys agree with that? So the arithmetic average is just you add those 2 numbers, you divide it by 2, you would get 25%. Okay, so it looks like this stock did pretty well. On average, arithmetic average, it had 25% return. Looks pretty good. But notice that this portfolio didn't actually increase in value, right? If you have a return of 100% and then a negative return of 50%, you're just where you left off. Okay, so that's pretty strange. So therefore, they introduced the geometric mean. So that's different than the arithmetic mean where we add. This is the geometric mean. So what it does, it multiplies all the numbers and then it divides, it raises it to the power of 1 over n, where n is again the number of observations. So again, here the arithmetic average was 25% return, but you will see that the geometric mean would actually be 0. And that makes sense because the stock didn't increase in value here. You see that? That's the idea with the geometric mean. I will give you an example about that. Okay. Sometimes the average might be a lot to work to calculate. So therefore you have some mid-range. That's really easy. You take the lowest value plus the highest value and you divide it by 2. And that gives you some feeling of what the average probably is with the data. Do you guys have an idea what the downside is of this mid-range? Why isn't always a good measure for the average? So it's pretty quick to calculate. But what's the problem with the mid-range? For what is it pretty sensitive? So for example, if I have 2, 4, 8, 10. Yes, it's really sensitive to outliers. Very good. So here the mid-range would be easy to calculate. It's 2 plus 10 divided by 2, so that would be 6. So here, no problem. That's also approximately the average. But what's the problem? If I would make this a 10,000, then it is way too high, right? You would get 5,001 as your mid-range, which is not representative for this data set, especially if I only have one big outlier and for the rest all the numbers are low, for example. So the mid-range is very sensitive to outliers. That's the insight here. You also have the oh, sorry, something in the chat. Can you do the mid-range of 3 variables? Of course. You basically only need 2 variables or more, right? So for example, if you have 2, 3, 20, then here the mid-range would be 11, right? So 2 plus 20 divided by 2, 11. So you just need 2 or more variables in your data set. You also have the k% trin mean. There you discard the k% highest and the k% lowest observations. So for example, if you have 10% trin mean and you have 20 observations, then you throw out the 2 lowest and the 2 highest. So then you will only be left with 16 numbers after you trimmed the 10% lowest and the 10% highest, right? I will show you what it does. And then you just calculate the arithmetic mean, like we did in the previous example. And then there's something that's called the mean absolute deviation. The mean absolute deviation is almost the same as the standard deviation. The interpretation is also basically the same. What it does, it looks what is the difference between a number compared to the average, and it makes it positive. That's what those absolute signs mean. So even if the thing inside the lines is negative, it still makes it positive. That's what this absolute value means. And then it adds it together, and it divides it by the amount of observations. So I will also give an example of that. Okay. So here's a question. We have some data. Calculate everything on the previous slide and use the 10% trin mean. So I personally always like to sort the data before we get started, especially with the mid-range. It's really nice. Also, when we are going to make Boxplot later on, it's really nice. So it's always a good habit to always rank the data. That's just nice to do. So we have the 3 again, I think the 5, the 6, the 8, oh no, sorry, the 7 first, 7 and 7, and then the 8, the 9, and then the 11, and then the 100, right? Okay, just to check to see if we didn't forget any variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations as well. So we didn't forget to copy one number. Okay. So now we want to calculate everything from the previous slide. So the first thing was the geometric mean, right? So what you're doing with the geometric mean is you do 3 times 3 times 5. And you do that for each number. So you multiply that by each number all the way up to this 100, right? That's the geometric mean. And what do we do in the power here? Do you guys know that? One over what? With the power of 1 divided by? And the amount of observations, very good, so 10. Okay, if we do that, according to my my model, I get 7.98. So 7.98. That's the geometric mean. So it's a bit different than the arithmetic mean, where we add everything and divide it by 10. Okay. Then the next one that we want to calculate was the mid-range. So I take the lowest number, which is 3. I add it to this 100. And then I divide it by what? By 2, right? What do we get? Do you guys know it? What do we get? Take your time to calculate. Yes, 51.5. Very good. So notice that this one is really affected by outliers, right? This 100 was an outlier that pulls up the mid-range. So the mid-range is not that representative anymore. Okay. Then we had to calculate the trimmed mean, and we used the 10%. How does it work? How many observations will I eliminate with the 10% trimmed mean? So I have 10 observations, and I want to find the 10% trimmed mean. Which observations will I discard? I will discard the 10% lowest, which is 10% of 10 is 1. So I will discard the lowest observation, and I will discard the 10% highest observation. So this is just the lowest one and the highest one. If my n would be 20, I would discard the lowest 2 and the highest 2, right? That's basically how it works. Okay. So now we just eliminate the 3 and the 100, and then I calculate the average like we always did. So just the 3, this 3 here, right? Plus the 5, plus the 6, all the way up to this 11 here. And by which number do I divide it now? So basically added all those numbers you're seeing here together. And by which number do I divide it now? By 10?
8.
Yes, very good, by 8. Okay. Let's see what we get. We get a 7 here. If you add those numbers together, divided by 8, you would get 7. This is better, right? Because this corrects for outliers like this 100. So that's maybe better in this case. So the k% trimmed mean is really helpful when you have outliers. Okay. Is this slide clear so far? Then we will go to the last one. That was the mean absolute deviation, right? Okay, so let's have a look. So with the mean average deviation, you first calculate the x bar, like you always do. And then you get this 15.9. So I will erase this here. So you guys see what we did here? We just added all those numbers you're seeing here, and we divided it by 10. That's just the x bar. We already did that before, right? Then with the mean absolute deviation, you basically do the same as with the standard deviation, but a bit different. You want to find the difference between the observation and the average, and you want to make the difference positive, always. Now, really nice trick to make it positive is to say 3 minus the average. That will be negative, right? So you square it, it will become positive, and then you take the square root. So now this here will be a 12.1, right? Sorry, no, that's not correct. 12.9 will this be, because the difference here is 12.9. That's basically what happens here. Well, this tree is also a tree, so this difference will also be 12.9. And you do that all the way up to the last observation, all the way up to this 100. That will be 84.1, right? Okay. And that's basically what happens. So you take the difference between the average and the individual observation, and it will always be positive. That's basically what happens here. And then you add it all together, you divide it by 10, and you get 16.8. So is this one also clear for you guys? And it's a bit mathematically a bit different than the standard deviation, but it will always almost be the same. So it's just that here you take you both first take the you raise it to the power of 2, but with the mean absolute deviation you already do the standard deviation before you add it. Well, with the standard deviation you first add it and then you take the square root. So here you first do the square root, then you add it, and with the standard deviation you first add it and then take the square root. That's why you get a slightly different outcome, but the interpretation is basically the same. Okay, so let's have a break, and then after the break we will do the median in the box plot, and then I think we can then start with the probability theory, the most important topic of this week, and then we again have a second break later. So let's start with the first break. Shall we do a 5-minute break? Is that enough for you guys? 2 times 5 minutes, maybe a bit more. So let's say we start at 12.12. They have 8 minutes or something. So then you have to be back. All right. See you then, guys. Okay, are you guys ready to continue? So we just wait 30 seconds and then we will start again. Yes, are you guys ready? Okay. So what we're now going to do is we're going to make a box plot. And the idea is that you want to make some figure like this so that you can see how your data is distributed a bit. So you know what your lowest value is, your highest, and where most of your observations are. That's the idea with a box plot. To make it, you are going to divide your data into 4 quartiles. And I will show you how to make those quartiles. And I will show it with an example. Okay, so you get some data. Let's say you get your x, which is 7, 2, 6, 8, 4, and 10. So 7, 2, 6, 8, 4, 10, yes. And notice that you have 6 observations here, right? The first thing you want to always do is you want to convert it into a variable where it's nicely sorted. So your lowest value is 2, then 4, then 6, 7, 8, and 10, right? So that's the first thing you want to do, to sort it. Okay. Then there are different things you want to do. And I will, by the way, already write down the box. So this will be your Q0, Q4, then somewhere here you will have your box. And then this is your median here. Okay, it's not drawn on scale, of course, but normally you can do it. This is how it will look like. And we want to find the corresponding values here that we have. That's basically what we want to do. Okay. To get the Q0 and the Q4, it's pretty easy. You simply take the lowest and the highest value. Okay, so that's also what you see here in the summary. Q0 is just the minimum of the x, and the Q4 that you're seeing here is just the maximum that you have. Okay, so that's pretty easy. So what would be my Q0 here? Any ideas? What would be Q0? Yes, it's 2 indeed, because that's the lowest value. What will be the Q4? What is the Q4? Very good, the 10, because that's the highest value. So the Q0 and the Q4 are really easy, the lowest and highest value. Okay, then you have something that's the Q2, that's also called the median. Okay. To find the median, it is basically the number in the center. So let's say that you have, for example, 2, 7, 9, 10, 12. Then you have an odd number of observations, and then it's just the number in the center, right? So then it's the 9. That's then your median. But you can also have the situation that you have an even number of observations. So for example, 1, 7, 8, 10, 12, 14. So here you have an even number of observations, and a 6. You see that. Then you have 2 numbers in the center. So what do you then do? You simply take the average of the 2 numbers in the center. So here, with this blue data set, the median would be 9 here, right? Because that's the average of the 2 numbers in the centers. So if you have an odd number of observations, you simply take the number in the center. If you have an even number of observations, you take the average of the two numbers in the center. Okay, is that clear for everyone? And that's what I basically wrote down here in the summary. If it's odd, you take the number in the center. If it's even, you take the average of the two numbers in the center. That's basically what I wrote down here with math. It looks a bit difficult, but you still know how to do it. Okay, so my question to you guys is, we have an even number of observations in this example. What is the median here? Could you say it to me in the chat? Or you can say it with your microphone. Yes, very good, 6.5. So we have two numbers here in the center, and their average is 6.5. So this here will be a 6.5. That's the median, okay? Then we're almost there. Now we're going to do the two most difficult ones, the Q1 and the Q3. Okay, for the Q1 and the Q3, you will need a formula. And the formula can be found on your formula sheet and also here in the summary. Remember that the Q1 is the same as the 25th percentile, right? So to go from a quartile to a percentile, you multiply by 25. So for example, the second quartile, the median, is the 50th percentile. Okay. So the formula you can use is the percentile divided by 100 times n plus 1. So let's apply that to our example. P divided by 100 times n plus 1. Okay. So I want to have the first quartile, right? Q1. That's the same as the 25th percentile. So what I will do is as follows. I will do 25 divided by 100 times 6 observations plus 1. What do you guys get if you insert this into your calculator? $1.75, right? Okay. So we need a 1.75 observation. Okay. So what are you going to do? That's written here in the summary. You round this outcome, this 1.75, to the nearest integer. So, okay, I will do that. So I round this. What's the nearest integer? The 2, very good. And that's the 4. The 4 is my second observation, okay? So for the quartile 1, I use the 25th percentile. I insert it into the formula. That gives me a 2 rounded. So now I know I need to have the second observation, which is 4. So now I know that this number here should be 4. 4 is the first quartile. Is that clear for everyone? Or do I need to go through the steps one more time? All clear? So let me show you one more. Can I erase this? Yes. Okay. Why 4? Because when I fill in the formula from the formula sheet, it says rounded that I should take the second observation, and that's the 4. The 4 is the second observation. Okay. So let's do another one. The last number is the quartile 3 that I want to have, right? So Q3. Which percentile is that? Which percentile is the quartile 3? Very good, the 75. Because remember, to go from a quartile to a percentile, you multiply by 25. Okay. So I filled into the formula to know which observation I need to take. What do we get? So this formula is on your formula sheet. What do we get? What do we get? 5.25. Then we round it to which number? To the closest integer. So we round it to which number? Yes. And no, that's not the closest integer. The 6 is not the closest integer. Yes, the 5. Very good. So we round it to a 5. Okay. And now I know I need to take the 5th observation. So this is the first, second, third, fourth, 5th. So the 8 is the 5th observation, right? And there you go. So this third quarter will be 8. Do you guys see what we're doing here? Shall I go through the steps one more time? So you convert a quartile into a percentile, 75th percentile. You insert the 75 in here. Then it tells you that you should take the 5th observation, which is the 8. So that is quartile 3. And this is your box plot. Okay. Is this clear for everyone? How to make this? Because I have some excellent questions for you guys. No questions? No? Okay. Oh, by the way, you also have something that's called skewness, pretty important in this course. You can basically remember in this distribution, your outliers are on the right. So then you have you're skewed to the right. For example, if your outliers are on the left side, like here, then you're skewed left. So that's skewness. If you, for example, have a normal distribution, I try to make a nice normal distribution. Sorry for my drawing skills. If you have a normal distribution, you will see that it's symmetrical, right? Okay. But not only the normal distribution, there are also other distributions that are symmetrical. The normal distribution is the most famous one. Okay, so here's the thing you can remember. If you have outliers, is your median affected by outliers? So for example, if I have 3 observations, 5, 8, 10. What is the median here? What's the median of those 3 observations? It's the 8, right? Is this 8, the median, affected by outliers? If I would make this a 10,000, would the median be affected by it? No, right? Is the average affected by changing this 10 into a 10,000? Definitely, right? Yes. So the idea is that if you have outliers on the right, it pulls this average up so that it is above your median. Okay, so high outliers on the right pulls the median up so that it is above the median. That's the idea. If you have outliers on the left side, it pulls the median, the mean down so that it is lower than your median. That's what you're seeing here. Okay, the mode is not important in this course, but it's in the textbook. It's the one that has the highest frequency, the highest probability of being chosen. Okay. Within a normal distribution, which is symmetrical, and this what I'm going to say holds for all the symmetrical distributions, you will see that the median and the normal distribution are the same, right? So the median and the normal distribution, the median and the mean are the same if your distribution is symmetrical. And that's what I wrote down here. Okay. So I will give you some time for the exercise. And you can write in the chat when you're done. So write done in the chat if you have finished. And then we will discuss the solution.
Wat deden ze nou, mama?
Okay, so I see that 3 people already finished it. There are 20 people in this group, so I just wait a bit more. Okay, I think we can continue, right? Okay. So you should get something like this. Sorry. So how can you see that this is a left skew distribution? So here you have the median. And notice that this area from this to the left is way longer than this area. So the outliers are on the left. And that means that the distribution is skewed left. So that's what you can remember. Is this clear for everyone? Yes? Okay. Then here's another exam question. Write your answer in the chat. Oh, I cannot type anymore. Chat. Sorry, I don't know what I have. Write the answer in the chat using a private message. Yes, Kim, you can indeed remember it in that way. Very good. Okay, it's indeed quarter one. Very good. So you can see it like this. This is Q0. And then this tree has to be Q1, Q2, Q3, Q4, right? Where this is the median. Okay. Next question. You can again write your answer in the chat using a private message. Also you, Wissam. Oh, I forgot to say that. I'm sorry. There are two other things I forgot to discuss. You have the range and the interquartile range. So the range here would be the difference between the highest value and the lowest value. So the range in this picture here would be, what would the range be? It would be 16 indeed, right? You have also the interquartile range, and that's the range of this box. Do you have an idea what the interquartile range is in this exercise, in this picture here? So this was 52 minus 36, 16. Yes, very good. It's 48 minus 43. So that would be 5 here, right? Yes. Okay. I forgot to tell about that. Okay. Then you can do the other exam questions. So I have to be honest, the exam questions about the first week regarding this topic are just a bit easy, but it's just a bit theory what I did so far. But it will get more difficult, unfortunately. So I think you guys already submitted your answer. So what is the thing they're asking for? it's indeed the interquartile range here, right? This is another exercise. So it's basically the same picture, but they use it more often. So this is indeed the interquartile range. Pretty good. Okay. Here's another exam question. Please submit your answer with a private message again. I already see the first answer. Second answer. All right, I will discuss it. So you sort the data from low to high, right? So 0, 1, 2, 4, 5, 7. Then you check, okay, we have 6 observations, and that's even, right? So then you have to take the average of the 2 observations in the center, and that average is 3. So the correct answer was 3. That's what the answer was that you had to submit. Is that clear for everyone? Okay. Yeah, I think so the question is it always good practice to sort the data in order to first to answer the question, no matter what the question is? Well, I think it is. For this first week, definitely, I think. Not always necessary, of course. So if you just want to calculate the standard deviation or the variance, it's not necessary. But if you're doing something with the median and the mid-range, that kind of stuff, then it's really nice to do that. Yeah. Okay. All right. The third main topic of today. Are you guys ready for the third main topic of today? Or do you want to have a small break again? I don't think so. Maybe just wait until a bit after 1 o'clock before we have the second break. Is it okay with you guys? Okay, great. So we're going to discuss probability theory, and I'm now looking for a nice example. Don't have it here. I will do it later. Okay. So with the probability theory, the first thing you need to know is the sample space. The sample space is the set with all the possible outcomes of the experiment. So for example, if you throw a coin, you can either throw heads or tails, right? Those are all the outcomes. If you throw a die, then you have 1, 2, 3, 4, 5, 6 as your possible outcomes. That's the sample space. Okay. Eventually, you need to be able to calculate and to understand everything that you're seeing on this slide. And I will use a small example to do that. So let me see what the numbers were that I had in mind. those are the numbers 0.5, 0.1. And I will tell you what that will be. Zero point 1 B A N. Okay. So back to the slide. Sorry, we go back again to slide 24. Okay, what is the PA? The probability of A in my example will be the probability that you are a male. So 50% chance that you're a male. And this 0.1 will be the probability that you have a criminal record. Criminal record. And then what does this mean? This is the AND situation. So this is the probability that you are a man with a criminal record. Okay. So this sign means intersection, and I always call it AND. Okay. So what you can do is you can draw a Venn diagram. The Venn diagram looks a bit like this. You have two circles. So this is circle A, this is circle B, and then this is the intersection. Okay. And we now, for example, know that this total size of circle A is 0.5. The total size of circle B is 0.1. And the intersection is 0.75. Okay. That's the probability that you are both an A and an B. Okay. Do you guys have an idea? What is the this area here? So basically this area. So remember the total circle A is 0.5. The intersection here is 0.075. So what is this blue area? Do you guys have an idea? Yeah, 0.5 minus the 0.075. So this will be 0.425, right? And that's basically the probability that you're a man without a criminal record. So 52.5% of our population is a man without a criminal record. What is this area here? So how did we get the 0.425? Can I repeat it? Of course. So we know that this total circle is 0.5, right? Because we said that the probability of A is 0.5. And also it was given that the intersection is 0.075. Then the other one has to be 0.425. So remember, together it needs to add up to 0.5. That's not the case, right? So is that clear how I got this number? Because it in total should be 0.5. Okay. So remember, circle B should be the area 0.1. So it's not drawn on scale, but what is this number here that you should get? 0.025, right? So that together it adds up to 0.1. And what would this be? Those are not males, right? Those are females. How many percent of your population is a female with a criminal record? So it's not a male and it has a criminal record. It's not an A, but it is a B. So 2.5% of your population is a female with a criminal record. That's basically what the interpretation would be here. Okay. Is this clear so far, how I got those numbers? So let me make it blue if I calculate it myself. 0.025 4 to 5. And then the red numbers were just given in the question. Okay. Is it clear how I calculated this? Oh, okay. With a Venn diagram, you know that all the numbers together should add up equal to 1, right? All the probabilities together are equal to 1. So do you guys have an idea what the area is of everything outside the circle? So basically this area here. So everything outside the circle. Remember, all the probabilities, all the areas should add up to 1. So what should this be here? So you add those 3 numbers together, and then you look, okay, what do I need more to get 1? Do you guys have an idea? What gives you the first number? 0.4, 7, 5, right? Do you guys agree that those 4 numbers together equal 1? Do you guys agree with that? Yes. Is it clear how I got those 3 blue numbers? Those 2 should add up to a half, the probability of A, and those 2 numbers should equal up to 0.1, and those 4 numbers should equal up to 1. Okay, that's how you get those numbers. Okay. So this is the probability of being a male. What is the probability of not being a male? Question to you guys. It is 0.5. No, 0.5, right? Because together you're either a male or you're not a male, right? You're an A or you're not an A. So you're 0.5, 0.5. Let's see. Probability of not being a B. What's the probability to do have a criminal record is 10%. What is the probability that you don't have a criminal record? Any ideas?
0.9.
Yeah, very good. So again, this is the probability to be a male with a criminal record. What is the probability to either have a criminal record or to be a male? So what's the probability to be a male or to have a criminal record, or both, basically, right? So this is the or situation. It's also called the union. So what is the probability that you're at least in one of those 2 circles? There are 2 ways to calculate this. You can add up those 3 numbers. What do you get if you add up those 3 numbers?
.675. Oh no,
No.
never mind. Sorry.
What do you get? So what is the probability that you're at least in one of those 2 circles? So you can simply add up those 3 numbers.
1.4.
Kim gave the correct answer. That is 0.525. Like this. So if you add those 3 numbers together, get 0.525. Okay. And I call this the or situation, the union. The probability that you're either a male or a criminal record or have a criminal record to both, that's 52.5%. Okay. There's also another way to do it, to find this or situation. And that's the general law of addition. So the general law of addition has the following formula. The probability to be either an A or an B, or both, is the probability of A plus the probability of B minus the probability of A and B. Okay. What is the idea here? So we basically want to have this area here, right? This is the area we want to have. That area is 0.525. What you can do is you can take the PA, which is this whole circle here. Then you add the PB, which is this whole circle here. But then you took the intersection twice, right? This part, the intersection, you took it twice if you add those two circles. So therefore, we correct for it by subtracting the intersection. Does it make sense to you guys? So I take circle A plus circle B, but then I took the intersection twice. So I subtract the intersection to correct for that. That's what the general law of addition tells us. So if you do that, you get 0.5 plus 0.1 minus 0.075. And do you get the same answer as when we simply add those three numbers? Do we get the same answer? Yes, we get the same answer, right? So that's the general law of addition. And for one of your quiz exercises from this week, you needed the general law of addition. So union means A or B, or both indeed. And the intersection means A and B. You needed all, you needed both. Yeah, very good. So is this general law of addition clear for you guys? Can I erase it? Yes? Okay, then it's gone. And always just feel free to slow me down. I cannot, normally if I teach you in person, I can see if you're still writing. Here I can, so please tell me if I cannot delete it yet. Okay, now we're going to talk about conditional probabilities. So if we go back to the PowerPoint, we now discussed the first four. We also discussed the general law of addition. We will now talk about conditional probabilities here. Okay. So what you're seeing here is the probability of being an A given that you are a B. So what is the probability that you are male given that you have a criminal record? How do you have to visualize this? The numerator here will be this intersection. The probability that you are an A and a B. And it is a condition, so conditional that you are a B. So we already know that you're in this circle. So that will be the probability of B here in the denominator. So you can remember the letter after the line, that will be in the denominator, right? And both the two letters will be in the numerator, okay? So it's this area, numerator, divided by total area. Okay. So it will be 0.075. That's the probability of being an A and a B. Divided by what? (0.1). Very good. And what do you get? You get 0.75, right? What is the interpretation of that? 75% of everyone with a criminal record is a male. And it means that what's the probability that you're being a female given that you have a criminal record? Yeah, that's of course 25%. So 75% of all the people with a criminal record is a male, and only 25% is a female. That's what we now found out. Okay. I'll come later to the second part. We can also switch letters. So we say, what is the probability of having a criminal record given that you are a male? So how do you visualize this? We want to have this area here divided by this total circle. So again, we want to have this intersection here divided by this total circle. That's what we want. Okay. So this intersection is probability of A and B. And what do I do, PA or PB here? Yes, PA. So what do I put in the numerator? 0.075. What do I put in the denominator? 0.5. Very good. And could you guys plug this into your calculator? I don't know what you get. I think you get 15%, right? Yes, very good. Could somebody give me the interpretation of this? So here we said from all the B, 75% is an A. From all the people with a criminal record, 75% is a male. What is the interpretation of this number here? You can turn your microphone on and try to give me an explanation. So what is the interpretation of this number? Yes, very good, Charlotte. From all the males, 15% has a criminal record. And that means that 85% doesn't have a criminal record, right? Okay. Is the conditional probability clear for you guys? What the meaning is and how you can calculate it? Yes? So we have PA, PB, the AND situation, the OR situation, and you can also calculate the OR situation with the general law of addition. And you now know how to calculate the conditional probability. Can you tell the meaning of the conditional? Of course you can. So the meaning is that you already know that the letter after the line is true. So you already know that B is true, and you already know that A is true, because that might affect the probability. So in my example, for example, you will see that given that you are a male, you have a higher probability of having a criminal record than when you are a female. So that's what we do with conditional. So we're not simply looking at the probability of A, but we put it on the condition. So for example, here, the probability of having a criminal record given that you're a male is 0.15. You can also do that for females, right? The probability of having a criminal record given that you're a female. Okay, we can calculate that. Let's see if that's also 15% or maybe a bit lower. So what you would do here, is we said you take the two letters that you're seeing here, and you would divide it by A prime. We don't have this one yet. Sorry, I cannot do this one yet because I need to first introduce the contingency table before I can do this. But you will see that this would be a lower number. So this is the probability that a female has a criminal record. And this is the question, what is the chance that a male has a criminal record? You will see that this number will be higher than this number. So that's the idea. I will later show you how to calculate this as well. Okay, you're welcome. Okay. Is it clear so far? Yeah, of course. So can I give the interpretation of this one again? Okay, given that you have a criminal record, there's a 75% chance that you are a male. So given that you have a criminal record, there's a 75% chance that you are a male. In other words, from everyone with a criminal record, 75% is a male and 25% is a female. That's what you're welcome. Any other questions? Okay. Last thing about the theory, and then I think it's time to have a break. So I think you now know what everything is on this slide. Probability of being a male, probability of being having a criminal record, probability to be a male with a criminal record, probability to, oh, sorry, no, this was the or situation, I'm sorry. So the probability that you are either a male or you have a criminal record or you are both. And this is the probability to have a criminal record and to be a male. This is the probability to be an A given that you're a B. So the probability of being a male given that you have a criminal record. This was the probability that you have a criminal record given that you're a male. Probability of being B given that you're an A. If this one is 0.5, then the probability to not be an A is 1 minus that. If this is 0.1, then this will be 0.9, right? If you 10% has a criminal record, then 90% doesn't have a criminal record. Then the last part, mutually exclusive. When you are mutually exclusive, two things cannot be true at the same time. So for example, I cannot be born in the Netherlands and in England. Those two things are mutually exclusive. So if you ask what is the probability to be born in the Netherlands and to be born in England, you will say 0 because it's mutually exclusive. Does that make sense to you guys? Yes? Okay. Then after the break, I will continue with some more theory. I will show you the contingency table. And then we are going to do a lot of exercises to make it, and then it will be more clear, right? Now it's just a theory. Okay, so let's have a break. And then we continue at 13.15, okay? So then we continue. See you then, guys. Okay. Are you guys almost ready to start? And we start in 30 seconds. We'll get some water real fast and then we can start. Okay, let's get started. So we already discussed the general law of addition. That was a nice way to calculate the probability of A or B. Of A or B. Here's something I want to show you. So we already discussed this formula, right? That was the formula for the conditional probability. You could remember the letter after the line, that will become in the denominator. And the two letters you're seeing here, that will be in your numerator. But sometimes it can happen that the end situation will be unknown. So then you need to rearrange that formula to calculate it. So you can basically remember this: the conditional probability times the probability of B here will be the end situation. And you can remember it as follows. If you have the B after the line, you multiply it with B. So for example, you also had this probability formula. If you have the A after the line, you will multiply it by A to get the end situation. So that's what you can remember. Okay, they both will give the same answer, of course. We will use that later during the session. Okay. So here's something important to understand. This is about testing whether A and B are independent. Okay, so if 50% is a male and 10% has a criminal record, how many people do you expect to have to be a male and to have a criminal record? What do you guys think? What do you guys think? Yeah, 0.05, right? However, I don't know if you remember our example, but this wasn't true. The actual probability to be a male with a criminal record was 7.5%. So what does that mean? That males in criminal records are not independent in our example. If you are a male, there's a bigger probability to have a criminal record than when you're not a male. So the idea is that you can check, is this equation true? Then it's independent. But if it's not true, like in our example, then it's dependent. Okay, so the interpretation is being a male increases the probability of having a criminal record. That's the idea here. It's not independent. There are also two other ways to check it. So for example, this probability was 0.5. Do you guys remember what this probability was? The probability to be a male given that you have a criminal record? I think it was 75%, right? Is that correct? In our example, I can go back to the whiteboard. 75%, right? So this second thing isn't true. This here in our example was 75%. And also that is evidence that it's not the independent, it's dependent. So basically what the interpretation in words here is from all the people with a criminal record, 75% is a male, while 50% of your population is a male. So basically, if it would be independent, you would expect that 50% of your people with a criminal record is a male, but we see that 75% is a male. So that is evidence that being a male increases the probability of having a criminal record. Okay. Is that one clear for you guys? Could you guys interpret the third line? So what was the value of this one again? Could somebody describe this in words? The probability of being? It is the probability of being a what? A B given an A. So the probability of having a criminal record, given that you are a male. Okay. So what was that probability again? I think we calculated that was 15%. Okay. So 15% of all the males has a criminal record, while the probability for the whole population is only 0.10. So basically, males have a higher than average probability to get a criminal record. That's what we calculated here. 15% of all the males has a criminal record, while for the population, only 10% has a criminal record. So males have a higher probability to have a criminal record. Therefore, it's not independent, it's dependent. That's the idea here. Do you guys get what independence is? That it's unrelated? And those are the three ways to check it. Okay. So what should you know for the exam? So on the exam, they could say, assume A and B are independent. And then, for example, those three formulas are true and you can use them. So that's one situation why this is helpful to know. They will say, assume A and B are independent. And then they're allowing you to use those three formulas. Only then you're allowed to use them, okay? Else you cannot just use them, because in my example, for example, they're not true, so you cannot use them. Okay. Only if it's independent you can use the formulas. Second situation of your exam is they say, test whether A and B are independent. And then you can choose which of the three formulas you choose. And then in my example, you will see that if you choose one of those three formulas, it is not true. And then you've proven that A and B are not independent. In my example. Okay. But I will show you some exercises, of course. Okay. Last thing, and then I promise you that we will start practicing. I'm sorry for talking so much. It's the contingency table. It's a really nice table. I will show you how it works. Okay, so you have A, not A, B, not B. And then here's the probability to be an A and a B. Here's the probability to be an A and not a B. And then if you add those two probabilities together, you get the probability of A. This is the probability to not be an A and a B. And if you add those two together, you get the probability of B. Here's the probability to be not an A and not a B. And if you add those two together, you get the probability of not being an A. Those together are the probability of not being a B. Do you guys have an idea? If I add those two together, what will I always get? Probability of A plus the probability of not being an A. What will you always get? 1. Very good. Okay, so this is the contingency table. And it's very helpful. I will show you what you can do with it. So now I wrote down the legenda. And now I will show you why it's so helpful. Okay. Do you remember that from the question, we got that the probability of A is 0.5. This number here is 0.5. The probability of B is 0.1. And the probability of A and B is 0.075. Those numbers are given. And this one is also always given, right? You know that it's always one. So basically, we have 5 unknown numbers that we want to find. And we can use the contingency table to do that. So if I now, for example, would ask, what is the probability of not being an A? We know that this should be 0.5, right? 0.5. What is the probability of not being a B? 0.9. So this is 0.9. But also the more complicated, what is the probability to be a female with a criminal record? To not be an A with a criminal record? Then, do you guys have an idea? This one will be 0 to 5, because those together will be equal to this one. Do you see that? So that's really helpful. Could you guys tell me what this number should be? This one here? Yes, very good, Kim. So 0.425. That's the probability to be an A and not a B. So the probability to be a male without a criminal record. Then there are 2 ways to calculate this one. And that's a nice check as well. So this should be 0.475. And that's because those two together should be equal to 0.5. Or because those two should be together to 0.9. So there's 2 ways to get that last number. Okay. So that's the contingency table. Is that one clear for you guys? Very helpful, very good to use with your exams. And also there was a quiz question about it this week. Okay. Then you have the conditional contingency table. You have 2 conditional contingency tables. I will show them in the PowerPoint. You have the given A table and the given B table. Okay. Let's start with the given A table. B, not B. Okay, so the idea is as follows. Given that you are an A, you can either be a B or you're not a B, right? Given that you're male, you either have a criminal record or you don't have a criminal record. So does it make sense that those two together are equal to 1? Does it make sense to you guys? Okay. Given that you're not an A, you can either have a criminal record or you don't have a criminal record, right? So does it make sense that those two together also equal up to 1? We'll move this a bit to the right, by the way. So those two are equal to 1. And those two are equal to 1. Does it make sense to you guys? Okay. So let's fill it in. We already calculated this 0.75, right? Sorry, this 0.15. 0.15. Do you guys agree with that? We already had that. The probability to have a criminal record given that you are a male, that was 0.15. Okay. My question to you guys is, what should this number be? What should that number be? $0.85. Very good. So this is 0.85. Okay. For those two numbers, we don't have we don't know the answer yet. So we need to find one of those two. Let's see if we can come up with that. So for example, if we want to have B over A, what we did, we set probability of A and B divided by the letter after the line. So divide by A, right? Do you remember that formula? But here we want to get this number here. So this is B A prime. So what do I put in the numerator? What do I put in the numerator? This is just a recap. Yes, I now use the A prime instead. And what do I use in the denominator? What do we use in the denominator? The A prime, very good. And this is where the previous contingency table comes in. Because this probability here, A prime and B, can be found by looking in the A prime and the B column. So now I can see it's 0.025. Do you see that? That's the idea here. So 0.025. The PA prime, that was this number here, right? 0.5. So this is why the contingency table is so helpful. Okay. And what do I now get? What do we get? $0.05. Everybody agrees with that? Yeah, I agree with that. Could somebody interpret this probability if you relate it to criminal records and males or females? How would you interpret it? You can maybe unmute your microphone. It's the probability to have a criminal record given that you are a female. Very good. The probability that you have a criminal record given that you're a female is only 5%. Then what is the probability to not have a criminal record given that you're a female? So 5% probability to have a criminal record. What's then the probability to not have a criminal record given that you're a female? Yes, very good. 0.95. Okay, very good, guys. That's the first conditional contingency table. Okay. If this is clear and there are no questions, feel free to ask them. I will go to the next slide for the second conditional contingency table. Okay. So remember that here we said given A or not A, right? Now we're going for the second conditional contingency table, where we say given B or not B. Given B or not B. right? So here we said given A or not A, but now we say given B or not B. So let's call it the second conditional contingency table. Pardon, this should be an A prime. Sorry. Okay. Notice that given that you're a B, you can either be an A or not an A. So therefore the ones will now be below it. Given that you're not a B, you can either be an A or not an A. So therefore the one will be below. You see that? And in the other situation, the ones were on the right, but now the ones will be below. Okay. So we'll write it down here. Like this. All right. So I think we already had this number here. Does anyone remember what it was? Probability of A given that you're a B. We had it here, right? 0.75. So the probability to be a male given that you have a criminal record is 75%. Then what is the probability to be a female given that you have a criminal record? Any ideas? Yes, very good. 0.25. Okay. Now I need somebody to get this number. Is it okay if I ask somebody? I would just pick somebody randomly. And so I will ask Nadine. Nadine, what was the formula to get this probability, for example?
Formula to get A conditioned by B
Yes.
stuff is was A union or A intersection B epistles divided by probability of B epistles.
Yeah, very good. So the number on the right of the line, that will become in the, sorry, the letter on the right of the line, that will be in the denominator, right?
Yes.
And then the idea was that this one can be found in the contingency table. Okay, so A and not B. You can say which number it is. So A and not B. Do you see it?
I'm sorry, what
The A and the not B.
is yeah 0.425 425.
Then the probability of not B. Oh, do you see it in the table?
Yeah, it's 0.9.
Perfect. What do you get? Don't think you get a nice number, but
Get around 0.472.
yes. Could you interpret that number? This
It
is
means that the probability that A happens when you know that B does not happen is is like about 47%.
yes. And in our story, the probability that you are a male, given that you don't have a criminal record, is 47.2%. Very good. And what should this number be then?
Should be 1 minus 472, so
Yes,
528. I think.
perfect. And this is every single thing that they can ask on the exam. So we just did everything that can be asked. So thank you very much. So I know it's a lot we did today, but now this is everything they can ask about week 1. Okay. Shall we start with some exercises? So everything we did, it's also in the summary. Okay. Here's an exercise. What do you guys want? Shall I give you some time to work on it on your own? Or shall I ask somebody to help me? That I just write it down, but you tell me what to do. Do you want to do it yourself, or shall I ask one of you guys to do this exercise? What is smart? Shall I just ask one of you guys to help me? File, would you like to do this exercise together?
Yeah, sure.
All right. So this is the data. Maybe
Yeah.
it's nice to start with a nice Venn diagram.
All right.
Okay, so we see that the intersection is 0.05, right?
Yes.
That's this area. What should this number be? Should it be 0.40?
That would be 1 second. That would be 0.35.
Very good. Because this whole circle, that should be 0.40, right?
Yes.
What should this be? Should this be 0.5?
0.45.
Yes, very good. Because this whole circle should be 0.5. Okay. What should this number be? Everything outside the circle, what is that area?
1.
Yeah, all the probabilities together are 1. So what should this fourth number be? So that all the 4 numbers are together 1?
That would be 0.15.
Yeah, very good. 0.50. Is this clear for everyone? So those 4 numbers together are 1. All the areas together, all the probabilities are 1. Okay, so that's already your Venn diagram. What is the probability to be A or B?
That is 0.4 plus 0.5 and minus 0.05.
Yeah, so you're using the general law of addition, right?
Yes.
And what do you get?
That is 0.85.
Yes, very good. If I would add up those 3 numbers together, would that give me the same answer?
Yes.
Yes, because we're basically calculating what's the probability to be at least in one of those 2 circles. Very good. Okay, that's question B. Sorry, question A, I'm sorry. This is actually question D. I will shrink this. Maybe I can ask somebody else to help me with question B. Rafaela, would you like to help me? Maybe Wissam then? Are you still there, Wissam? Then I will ask Kim.
Yeah.
So what is the formula for this conditional probability?
It's the probability of A and B
Mhm,
divided by the probability of B.
very good. And what is the probability of A and B?
0.05
Mhm,
divided by 0.15.
yes.
That's 0.1.
0.1. 0.1? Oh yeah, of course, it's 0.1. I miscopied this one, sorry. So okay, very good, Kim. Who else do we have here? Yuki, would you like to help me with question C?
Yeah, sure.
What is
So
the formula?
this is P and then even kijken. A and then zo, hoe zeg het? Intersection with B divided by A.
Yes, very good.
So that will be 0.05 divided by 0.40.
Yes. What do you get?
That will be 0.125.
Yes. That's the first exercise. Thank you, everyone. Is this clear for everybody? Are there any questions? No? Then I will erase it. And I now erase it. And here's the answer model as well. Here's another exercise. Shall we again do it together, or would you like to have some time on your own? Shall we do it together? Charlotte, would you like to help me? No? Maybe Alana?
Yeah, I can try.
Okay. So we want to make a contingency table with this data, right? Maybe it's nice to make a picture of this and then to do it on the whiteboard, right? So I will
Yeah.
copy the information and then we can do it on the whiteboard. Okay, 1 second.
I'm trying to look, but I don't really think that I know.
No, I can help you, of course. So I will not. I will always guide you. So okay, so this is the probability of S. That is 0.246. This is the probability of C, which is 0.830. P, S, and C 0.232. And the first question is make a contingency table, and I will help you with that. Oh. Okay, shall we put S on the X on this side and then the C on the other side? Okay. maybe you remember, but this was the probability of S and C. Do you know what this is? The probability of S and
The C with
C
the
prime.
the
And
C.
what will that add up to together?
What? Oh no, sorry.
It will be S, not 1 indeed.
Just
It's often
PS, yes.
confused.
Sorry.
Yes. No,
Yeah.
no worries. And here we have P S prime and C. And what will this together be equal to?
PC.
Yeah, very good. And this will be both with a prime.
Is
And that
P-
will be PS prime, right? And this will be PC prime. And what will PS plus PS prime be? So those two
1.
together will be 1. Or those two together is also 1, right? So that's the normal contingency table. You also have two conditionals, but let's forget about that for a second. Okay. Now we're going to try to fill it in with numbers. All right. So I would just copy the numbers here. So PS was 0.246. PC was 0.830. PS and C was 0.232, right? Okay. How can I find this number here?
Just like maybe do the 0.830 minus the
Yeah.
0.232. 2, yeah.
Yeah. If you subtract those, what do you get?
Oh. Uh, 0.598.
Yes. If you subtract those two from each other, what do you get?
That is yes, 0.014 or
Yeah, 14. Very good. And if you want to know this number, for example, what is that?
oh, that's yeah, the 1 minus the 0. 0.17.
Yeah, very good. And then this one, with those two.
0.754.
Yeah, very good. And now we have two ways to find the last one. And we would use one of as a check, right? So I think those two are the most easy ones. That's
156.
56. And then if we add those two together, we should get this number, and then we know we did everything correctly.
Yeah.
And that's the case, right?
Let me check. Yes.
Those together will be equal to that. So perfect. Thank you, Alana. So that was the first question. That was question A. Okay. Then question B, there we want to have P. Well, from here on, it's pretty easy, I think, to get PS prime. Nadina, would you like to help me again? What is PS prime? Maybe Kim else?
0.754.
Yes. I will let you do some more because those are the easy ones, right? You can just read it from the table. Then the PS and C. PS and C.
Oh, should I answer?
Yeah, why not?
Oh, okay, right. It's
Sorry?
kind of forgot about.
Oh, so here we have PS and C.
Oh, sorry.
And that
Yeah, I blanked out. It's 0.232.
Yes. And I will also let you do the next one because this was just
All right.
looking it up in the table. So the
Right.
next one is probability of S given that you are C.
Yeah. So it's the probability of S and C divided by the probability of C.
Very good. Because remember the letter on the right of the line that will be in your denominator.
So
And-
that is 0.232
Mhm.
Divided by 0.830.
Yes, very good. What will that be equal to?
That's 0.279.
0.279. Does everybody have that? Okay, sounds good. Thank you. I will ask somebody else.
Okay.
Who's also there? Yuki, maybe again? I don't know. Am I forgetting somebody who wants to
Yeah, it's
help?
okay. I can help.
Okay. Yuki, question E. In question E, we want to know PS given that C prime is true.
Yeah.
So PS given that C prime. What is the formula of that?
I think intersection of S and C prime
Yes,
divided by C prime.
very good. Very good.
So that will be even kijken, 0.014
Mhm.
divided by 1 minus 0.830. So that is,
Well, we already have it in the table, right?
oh, yeah, that's 0.170.
Yeah, exactly. So what do you get?
And that is 0.082.
Okay. Did everybody have that? Yes. Okay. Thank you, Yuki. I will ask you one more question, and then I think we can better call it a day because you guys are probably pretty tired after those 3 hours of intensive training. So, are C and S independent? Okay. There are 3 ways to check it, right? You can just simply choose one to check it. So basically, I can show you that slide again. There were 3 ways to check whether it's independent. Those are the 3 ways, right? It's on slide 26. Which one would you want to choose to check if S and C are independent? The one above or the second or the third? You can choose. It doesn't matter, Yuki.
I guess the first
The
one.
first, all right. So what we basically are saying there is that if S and C are independent, then
The intersection should be same as A times B.
yes. Is that the case? So if you take this number times this number, do you get this number here? So this times each other gives you that number.
Not, I don't think so.
No. So this number times this number is not the same as that number. That's the idea.
So it's dependent, right?
Yes. So this number was 0.232. And what do you get if you multiply those two?
That even kijken hoor. 0.204.
So that's not the same, and therefore it's not independent.
Yeah.
All right. Is this clear for everyone? Because then that's the end of the session. No questions? All right. Well, thank you for the attention, and yeah, well done that you could last for so long. So it was a pretty intensive session, I think. All right.
Mark, I have one question.
Okay.
I remember you